Hello everyone, this is Mr. CFD and welcome to this training course on ANSYS SpaceClaim, and we will be your instructor throughout this journey. The goal of this course is to give you a clear, step-by-step understanding of SpaceClaim, from the very basics all the way to preparing geometry for simulation inside ANSYS Workbench. What makes this course different is that we'll focus on a hands-on, practical approach. Instead of overwhelming you with theory, I'll guide you through the essential tools, explain how they work, and show you how to apply them in real engineering workflows. So whether you've never used SpaceClaim before, or you're looking to refresh your skills, by the end of this course, you'll be confident in navigating the software, creating and editing geometry, and preparing your models for analysis. Now that we've introduced the course, let's answer a very important question. Why should we use SpaceClaim? The first reason is speed and simplicity. Traditional CAD tools can be quite complex, especially when you need to make changes to your model. You often have to go back through sketches, constraints, or parametric features. SpaceClaim, on the other hand, uses what we call direct modeling. That means you can simply push, pull, and move faces or edges of your geometry, almost like sculpting the model directly. This makes the modeling process very fast and very intuitive. Second, SpaceClaim is perfect for engineers who don't want to get lost in the small details of CAD design. If your main goal is simulation, analysis, or rapid prototyping, you probably don't need every single manufacturing feature in your model. SpaceClaim gives you exactly what you need: a clean, easy way to build and modify geometry without requiring advanced CAD expertise. And third, SpaceClaim is widely used for some very common applications in engineering workflows, preparing geometry for meshing in ANSYS Mechanical or Fluent, removing unnecessary details like small fillets, holes, or complex features that only slow down your simulations. And of course, quick conceptual design, creating or modifying 3D ideas in minutes so you can test them right away in your analysis. So in short, SpaceClaim saves you time, reduces complexity, and keeps you focused on the actual engineering and simulation work, instead of spending hours adjusting CAD features. In the next part, we'll take a quick look at the history of SpaceClaim, where it came from, and how it became part of the ANSYS ecosystem. Before we move on, let's take a quick look at the history of SpaceClaim, because understanding where this software came from helps us see why it's so unique. SpaceClaim was founded back in 2005 by a team of engineers who wanted to rethink how we interact with 3D geometry. At the time, most CAD tools were heavily parametric, meaning every design depended on a history tree of sketches, features, and constraints. While that was powerful for manufacturing, it also made modeling and especially editing very slow and complicated. If you wanted to make a small change, you often had to step back through the entire history of the model. The founders of SpaceClaim decided to focus on something different: direct modeling. Instead of relying on a history tree, SpaceClaim lets you work directly on the geometry itself. You push, pull, move, and combine features in a very natural way. This approach made the software much faster, more flexible, and most importantly, accessible to engineers who don't necessarily have years of CAD training. Because of this fresh approach, SpaceClaim quickly gained attention in industries where engineers needed to modify existing CAD data or quickly prepare designs for analysis. It solved the problem of spending hours on CAD when your real goal was simulation or product testing. Then in 2014, the company was acquired by ANSYS. And that was a turning point, because ANSYS integrated SpaceClaim directly into its ecosystem of simulation tools. Today, when you open ANSYS Workbench or Mechanical, SpaceClaim is often the go-to environment for preparing and simplifying geometry before analysis. In other words, what started as an independent CAD tool has now become a core part of the engineering simulation workflow. So to summarize, founded in 2005 with the idea of simplifying 3D modeling through direct modeling, SpaceClaim broke away from the complexity of traditional parametric CAD systems. In 2014, after almost a decade of success, it was acquired by ANSYS, and since then it has become an essential tool inside the simulation world, helping engineers prepare geometry, clean up models, and accelerate workflows. All right, now that we understand the background and history of SpaceClaim, let's move on and see how it fits today inside the ANSYS ecosystem and why it has become such a valuable bridge between CAD and simulation. Now let's compare SpaceClaim with other CAD and CAE tools, because this really highlights what makes it different. Traditional CAD software, like SolidWorks, CATIA, or Creo, is parametric and feature-based. That means each part of your design is built step by step. You start with sketches, you add features, and everything is stored in a history tree. This method gives you extremely precise control over every detail, which is perfect when your goal is manufacturing or creating detailed production drawings. But it also has a drawback. Every change depends on the history. If you want to change the size of a hole or move a surface, you often need to go back to the original sketch, modify constraints, and then rebuild the entire model. That can take time and sometimes cause errors. Now let's look at SpaceClaim. Instead of parametric modeling, it uses direct modeling. That means you interact with the geometry itself. You can simply push, pull, move, or merge surfaces directly, like sculpting the model with your hands. There's no feature tree to worry about. This makes SpaceClaim much faster and more flexible, especially when you're preparing geometry for simulation, removing unnecessary details, or testing ideas quickly. Let me give you a simple example. Imagine you have a block with a hole through it. In a parametric CAD system like SolidWorks, if you want to move that hole, you'd need to open the original sketch of that hole, change the dimensions or constraints, and then rebuild everything. In SpaceClaim, you just select the hole and drag it to the new location. That's it. Simple, direct, and instant. This difference in workflow is really important. If your primary goal is creating highly detailed designs for manufacturing, a parametric CAD tool is usually the better choice. But if your focus is on simulation, prototyping, or quick geometry edits, then SpaceClaim is the faster and more practical option. It gives you freedom from the complexity of feature trees and allows you to focus directly on your engineering task. So in summary, traditional CAD means precise, parametric, and manufacturing-oriented. SpaceClaim means direct, fast, and simulation-friendly. Both are powerful in their own domains, and together they can form a very complementary workflow. The primary role of SpaceClaim in ANSYS is at the pre-processing stage. Before we can run a simulation, whether it's structural, thermal, or fluid, we need a clean and simplified geometry. Raw CAD models often contain unnecessary details, like small fillets, tiny holes, or cosmetic features. These details don't usually affect the physics of the problem, but they make the mesh much heavier. SpaceClaim allows us to quickly remove or simplify those features, making the geometry simulation ready. Another advantage is that SpaceClaim is directly integrated with ANSYS tools. For example, it works seamlessly with ANSYS Mechanical for structural analyses and with ANSYS Fluent for fluid flow simulations. The handoff is smooth. You don't have to export complicated files or spend time fixing compatibility issues. You prepare the geometry in SpaceClaim and then send it straight into the solver environment. The real value added here is efficiency. By using SpaceClaim, engineers can save a significant amount of time in the simulation process. Complex projects become more manageable, and the overall workflow is simplified. Instead of struggling with CAD constraints, you can focus on the actual analysis, which is what really matters. So, in summary, SpaceClaim acts as the geometry preparation bridge in the ANSYS ecosystem. It cleans and simplifies the model, ensures smooth communication with Mechanical and Fluent, and ultimately helps engineers run faster and more reliable simulations. So to wrap up today's session, our main goal here was simply to introduce you to the essence of SpaceClaim, understanding what it is, why it was created, and how it fits into the ANSYS ecosystem. This background gives us the big picture. Starting from the next sessions, we'll move fully into the software environment itself. Everything will be hands-on. We'll go step by step through the tools and commands you need to build and edit geometry, and we'll practice together on actual models. So today was the theory and history, and from the next lesson on, everything will be completely practical. I hope this video was useful for you. To benefit from Mr. CFD's services, including simulation, consultation, and training, visit our website and contact us via these addresses.